When working with colors, you will often see people share colors using these hexadecimal codes. Especially if you are doing web design, most likely you already used these hexadecimal codes to define colors in HTML or CSS codes. If you open Blender's color picker, you can see the hex tab in here, where we can input color or copy and paste the color in hexadecimal code format. Usually, in other graphics software, hexadecimal color code preceded with a hash mark or a sharp symbol like this. In this video, we are going to discuss the underlying structure of these hexadecimal color codes, so later you can use them confidently and be able to change the color just by tweaking the numbers. Quick explanation first. These hexadecimal codes can be divided into 3 groups, each with double digits. So the first 2 digits are actually for red color, the second 2 digits are for green color, and lastly, the third 2 digits are for the blue color value, okay? You might be wondering by now, how come we have these numbers and letters all mixed up like this? In standard RGB 8 bits per channel images, each channel will have 8 digits, and in each digit, we can have a value of 0 or 1. Now, if we divide these 8 bits into left wing and right wing, we can have 4 digits at the left and 4 digits at the right. Because we have 4 probable spaces and each with 2 possible values, we can calculate the maximum number of variations we can have, and that will be 2 powered by 4 equals to 16 variations each, okay? So each wing can have a value between 1 to 16. But if we start from 0, then we get 0 to 15 values. The idea here is how can we write each of these wing with only 1 digit, not 4 digits like this as when we are using binaries, or not using 2 digits like this as when we are using decimal. The answer is by writing the value in hexadecimal. So what is actually hexadecimal? Well, we all know about decimal, right? We count from 1, 2, 3, up until 9. Then after we reach 10, we actually doing a loop here. We are back to 0, then 11, 12, 13, etc. Basically using decimal, for each 10th value, we are looping the counting order. This behavior exists mostly because we as humans have 10 fingers. Now just imagine here for a second. Let's say you encounter an alien race that has 16 fingers instead of 10. How do you think they will count numbers? Using the decimal system? Not likely. Big chance they will use a hexadecimal system. Hexadecimal system loop the counting order not when it reaches the amount of 10, but when it reaches 16. Now, if we borrow this system, we can use only 1 digit to refer the value of each of these wing. But wait, we still have a problem here. We don't have number symbols greater than 9. How can we symbolize numbers like 10, 11, 12 until 15 in hexadecimal then? Well, we can hack it. We can use letters instead. So as decimal goes like this, 1, 2, 3, 4, until we reach 9. After that, we have 10, 11, and so on. In hexadecimal, we have 1, 2, 3, up until 9. We still have the same symbols here. But when we reach 10, we use letter A, then B for 11, and so on until F for 15. When we reach 16, then we have 10. So 10 in hexadecimal value is equal to the amount of 16 in decimal values. Okay, so by using this system, at 1 digit space, we can have a minimum value of 0, which is equal to the amount of 0 also in decimal, and the maximum value of F, which is equal to the amount of 15 in decimal. So now, with only 6 digits, we can define any RGB colors that we like. Sometimes, you will also encounter 3 digits color value, or also known as web-safe colors. Please don't be confused with these codes, as basically, they are double values. So for example, if we have 37A like this, the real value for this is actually 3377AA, 3377, and AA. Now, web safe color is a legacy of the old days standard when computers still have limited colors and also limited bandwidth. Nowadays, they're really not important at all. Several hints when working with hexadecimal values. When all of the values zero, either 6 digits like 000000 or just 000, using WebSafe color format, both of these numbers mean black. As in RGB color model, no light means black. If we have all of the values set to F, such as FFF or FFFFFF, this means the color is white. White is the strongest color as all of the RGB channels are set to its maximum values. Next, we also can tell if the color is grayscale, and that is when each number of R, G, and B values are identical. So for example, 12, 12, 12 like this, or 4E, 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 or CCC, all of these are grayscale color values.